Everything in the universe is in motion: planets, stars, galaxies. From the smallest asteroid to the largest supercluster, nothing stands still. The cosmos is a swirling, ever-changing dance, and Earth is just one participant in this grand ballet. But for us to join that cosmic dance, we need a massive push: rockets, powered by their fuel. Without that initial burst of energy, we'd remain forever grounded, watching the universe from afar. Rocket fuel is the bottled energy that lets us defy gravity and reach for the stars. It's the secret ingredient that transforms a pile of metal and electronics into a vessel capable of leaving Earth behind. To escape Earth, a rocket must hit about 25,000 miles per hour, an incredible feat requiring immense energy. That's more than 33 times the speed of sound, and it's only possible because of the explosive power stored in rocket fuel. The fuel, mixed with an oxidizer, creates a powerful exhaust that pushes the rocket upwards, Newton's third law in action. For every action there's an equal and opposite reaction, and in rocketry, that reaction is what sends us skyward. The story of space exploration is really the story of our quest for the most powerful and efficient fuels. Every breakthrough in fuel technology has opened new frontiers, making the impossible possible. The choice of fuel dictates the rocket's size, payload, and destination. It determines how much we can carry, how far we can go, and what kind of missions we can dream up. Powerful but heavy fuels work for short trips. Lightweight, efficient fuels are needed for deep space. The right fuel can mean the difference between a quick hop to orbit and a journey to another planet. Every historic launch, from Mercury to the Space Shuttle, relied on a carefully chosen recipe of chemical energy. Each mission was a testament to human ingenuity and our relentless drive to go further. As we enter a new era of space travel, the conversation about rocket fuel is more important than ever. Private companies and space agencies are racing to develop new fuels that are safer, cleaner, and more powerful. The fuels we choose now will shape humanity's future in space. They'll decide how quickly we can travel, how far we can explore, and how sustainable our presence beyond Earth will be. They'll determine if we can build bases on the moon, send astronauts to Mars, and venture even further. The right fuel could unlock entire worlds, turning science fiction into reality. The fire that lifts our rockets is the same fire that fuels our dreams of becoming a multiplanetary species. It's a symbol of our curiosity, our courage, and our hope for the future. Without the right fuel, we're just spectators to the universe. We can only watch as the cosmos unfolds, unable to take part in its wonders. But with it, the stars are within reach. The right fuel is our ticket to the universe, and the key to unlocking the next chapter of human exploration. Our journey to the stars began with simple ingredients, humble experiments, and a sense of wonder about what was possible. Robert Goddard's early rockets in the 1920s used liquid oxygen and petrol, a revolutionary idea at the time that set the stage for future breakthroughs. The Second World War accelerated rocket development, with Germany's V-2 rocket using ethanol and water with liquid oxygen as propellants. This alcohol-based fuel was stable and easy to produce, making it ideal for mass production and rapid deployment during wartime. After the war, American rockets like Redstone continued to use and refine these fuels, pushing the boundaries of what rockets could achieve. These early propellants got us off the ground and proved we could touch the edge of space, inspiring a new era of exploration. But as ambitions grew, alcohol's low energy density became a limitation for reaching further into the cosmos. To reach the moon and beyond, we needed something far more powerful, fuels that could truly take us to new worlds. The next leap in rocket fuel was kerosene, specifically rocket-grade RP-1. Combined with liquid oxygen, RP-1 was denser and more powerful than alcohol-based fuels. The Saturn V, which took Apollo astronauts to the moon, burned millions of pounds of RP-1 and LOX in minutes, generating staggering thrust. RP-1's stability at room temperature made it easier and safer to handle than cryogenic fuels. It became the workhorse of space exploration, powering rockets for decades. However, RP-1 leaves behind soot or coking, which complicates reusability. For expendable rockets, this wasn't a problem, but for reusable rockets, it's a major hurdle. The need for cleaner, more efficient fuels became clear as reusability became a priority. Engineers began searching for a better alternative. For pure efficiency, nothing beats hydrogen. Burning liquid hydrogen with liquid oxygen gives the highest specific impulse of any chemical rocket, maximum push for minimum fuel. The only exhaust is water vapor, making it clean burning. The Saturn V's upper stages and the space shuttle's main engines relied on hydrogen for their final push into space. But hydrogen is tricky. It must be kept at -253 degrees Celsius, is hard to store, and requires huge, heavily insulated tanks. These challenges make hydrogen expensive and complex, especially for first-stage rockets. While unmatched for deep space, hydrogen's difficulties on the ground led engineers to seek a middle ground. They needed a fuel with better performance than kerosene, but easier to handle than hydrogen. Enter methane. Methane, the simplest hydrocarbon, is now at the heart of the next revolution in spaceflight. When paired with liquid oxygen, methalox, it offers higher performance than RP1 and is much easier to handle than hydrogen. Methane burns clean, producing little soot, which is crucial for reusable rockets like SpaceX's Starship. Engines stay cleaner, reducing turnaround time and cost. Methane is cryogenic but manageable, stored at -162 degrees Celsius, much warmer than hydrogen. Its storage temperature is close to liquid oxygen, simplifying rocket design. This synergy streamlines vehicles and boosts reliability. Methane's biggest advantage, it can be made on Mars. This could transform deep space exploration, making Mars a refueling outpost. Methane is the key to sustainable, affordable, and reusable space travel. The dream of living off the land in space is becoming real, thanks to methane. For decades, scientists and visionaries have imagined a future where humans could survive and thrive on other worlds, using only the resources found there. Now, with new technology and bold missions, that vision is closer than ever before. Mars's atmosphere is 95% carbon dioxide and water ice is abundant. These two ingredients are the key to unlocking local fuel production, making Mars one of the most promising places for off-Earth industry. The planet's surface holds vast reserves of frozen water, hidden just beneath the soil and at the poles. Using the Sabatier reaction, we can turn Martian CO2 and water into methane and oxygen, rocket fuel and oxidizer. This chemical process, already tested on Earth, is the foundation for making fuel directly on Mars, reducing the need to haul heavy supplies from home. Imagine sending an uncrewed Starship to Mars with a chemical plant and power source. Before any astronauts arrive, the plant would get to work, using local resources to prepare for the crew's journey home. It mines water, splits it into hydrogen and oxygen, then combines hydrogen with CO2 to make methane. This automated process could run for months or even years, steadily filling tanks with precious fuel. The result? A fully fueled rocket ready for the return trip, all made on Mars. This means astronauts can explore further and stay longer, knowing they have a way back. This process, called in situ resource utilization, or ISRU, slashes the amount of fuel we need to launch from Earth. By making fuel where we need it, missions become lighter, cheaper, and more flexible. ISRU makes sustainable human settlement on Mars possible. It's the first step toward building a self-sufficient outpost where people can live, work, and build a new future. Mars becomes a stepping stone to the rest of the solar system. With local fuel production, we can launch missions deeper into space, reaching asteroids, moons, and even the outer planets. Methane-based ISRU could turn one-way trips into a network of interplanetary travel, connecting worlds and opening the door to a truly spacefaring civilization. The evolution of rocket fuel is transforming space from science fiction to reality. What once seemed impossible is now within reach, as new technologies and innovative fuels are rewriting the rules of space exploration. Methane and reusable rockets are lowering launch costs and opening space to more players. These breakthroughs mean that not just governments, but private companies and even universities can now dream of reaching orbit and beyond. Clean-burning methane engines promise greater reliability and safety. Their simple design reduces maintenance, while their non-toxic exhaust makes launches safer for people and the environment. Launch sites are becoming more automated, with on-site propellant production streamlining operations. Automation speeds up turnaround times and reduces human error, making launches more efficient than ever before. These advances expand humanity's reach, making permanent settlements on the Moon and Mars achievable. Living and working on other worlds is no longer just a fantasy, it's a real possibility for the next generation. Refueling on other worlds unlocks the solar system for exploration and commerce. With local resources, missions can go further, stay longer, and return more safely. Space travel could soon become routine, much like air travel did a century ago. Imagine boarding a spacecraft as easily as catching a flight with destinations that span the solar system. We're building the infrastructure for a spacefaring civilization. New spaceports, advanced manufacturing, and global collaboration are laying the foundation for humanity's future beyond Earth. The next leap, powered by better fuels, will take us further than ever before. Each innovation brings us closer to exploring the outer planets and perhaps one day, other star systems. The path to the stars is finally within our grasp, thanks to the chemistry inside our rockets. Our journey has just begun, and the universe awaits.